This is a follow-up to our video on why only one side of the moon faces Earth. Briefly, the moon is in a tidal lock where its rate of rotation and rate of revolution are matched in a 1-to-1 ratio. The reason for this lock is because the moon's center of gravity relative to Earth is closer to Earth than the moon's center of mass. Cool. But as with just about anything in science, one explanation merely leads to further questions, many of which I've seen from your comments. So in appreciation, I would really like to address some of your questions. 1. Why don't lakes experience tides? Quick answer, lakes aren't large enough. Here's the long answer. A tidal effect results when there's a difference in gravitational force, which happens with increasing distance as per the inverse square law. If that difference in gravity is significant, then the tidal effect will also be significant. This is the case when we talk about our oceans, which span the globe having a diameter of about 8,000 miles. For even the largest of lakes, the force of gravity from the moon, it's effectively the same across the entire lake. The lake is just too small for there to be a tidal effect. 2. By the same mechanics described in your first video, why isn't the same side of Earth always facing the sun? Again, the tidal effect results from a difference in gravitational force. The daytime side of Earth is about 93 million miles from the sun. The nighttime side of Earth, it's also about 93 million miles from the sun. Okay, about 8,000 miles farther, but 8,000 miles out of 93 million isn't much of a difference. Now, there is a sun-Earth torque working to slow our rate of rotation, but it's relatively weak. And the rotational momentum of Earth's spin, it's plenty to overcome that torque. Please understand, the gravitational pull of the sun is strong. The key idea is that the strength of the sun's pull is about the same across the entire planet. If it were perfectly the same, then its tidal effects would be zero. So, if the gravitational pull of the sun is strong, then why doesn't your hair stand up when the sun is directly overhead? And why doesn't your hair hang downward after jumping from a high diving board? And how is that second question actually the answer to the first? Think about that. All right. 3. But gravity isn't really a force. Yeah, we know that to be true. As per our videos on relativity, Einstein showed us how mass bends time and space. We witnessed that bending of time and space as this thing Newton identified as gravity, which to us has every appearance of a force. Calling it a bending of time and space or a force, it doesn't matter because both are sensitive to the inverse square law, which is what lies at the heart of the tidal effect. 4. Why do you talk so slowly? I could talk really fast too if I wanted. But how might that help you in learning these remarkable concepts? The inverse square law? Huh? In your learning, isn't it a good idea to take it step by step? Little steps, so you get to where you want to go, which for science is an understanding of the natural environment in which we all live together. Good energy.